Hello. I thought I would finish the two problems on this page for anybody who was hoping to see these solutions this weekend. We'll look at these problems also in class at the start of lecture on Wednesday when we return to class. So the next question here was looking at or saying if we have how many pounds of ethanol are present in 1.00 gallons of ethanol. So we are given the conversion between a gallon and a liter. This is actually a rounded value, but that's enough decimal places for the problem we need to do. Densities, this is probably the one experimental value that isn't all that precisely known, but it's known about 4 decimal places here, the density of ethanol. So let's try to solve for the number of pounds of ethanol. And so I always like to begin a dimensional analysis problem with what it is that we're looking for. It gives us a good starting point. And then the math can begin possibly with what we're given, is also usually a good starting point. We're given 1 gallon of ethanol. We want to know the pounds in that gallon, so that's a good starting point. Usually the worst case scenario with dimensional analysis, if we don't get the unit in the numerator where we're expecting it to be, we may need to flip a bunch of things and kind of do the problem again. But it's usually pretty straightforward to start these problems with what we're given here, a gallon of ethanol. We can convert 1 gallon to liters. Now, why do we convert to liters? Well, our density, our gram per milliliter, needs us to be in some unit of liters. So we go from gallons to liters, almost 4 liters in a gallon. And then we can convert liters to milliliters, so we can use our density conversion factors. We just have to kind of think ahead to needing grams per milliliter to be in the calculation. So we want to go 1 liter to milliliters. And we just have to remember milli is 1,000, so there's 1,000 milliliters in a liter. And then we're not done yet, no equals yet. So one more step is the 0.7894 grams per milliliter. So this is kind of the idea of a problem-solving technique with dimensional analysis, is I'm using my density as a conversion factor. It's just the ratio of the mass per unit volume. And so the way the math works here, the gallons canceling itself out, the liters canceling itself out, the milliliter cancels out. And we're also not done yet because we're not quite to pounds. We're in grams. So we want to do the conversion to kilograms. We're going to also use the conversion factor, have it given above the kilogram to pound conversion from the problem right above us. And so we need to go to kilograms to use that conversion factor. So we go 1,000 grams in a kilogram. This is a conversion factor that we just have to know. And all these other conversion factors would be given. Don't get too concerned about conversion factors. In fact, if you go to my daily quiz page where those quizzes are, you can go to lecture module, go to daily quizzes. There's a file with a bunch of useful information, and information is kind of tagged in that file that you would be provided with when you need it on exams. You get an exam sheet that has a couple equations, like the temperature conversions we were mentioning in class, and some other information. We'll post it soon for midterm 1 coming up. But we can always give extra information within a particular problem if you need it. So you'll see a sheet that doesn't have nearly probably every conversion factor that we talk about or use in chapters 1. In the later ones, we'll get into 2 and 3. But if you need extra values or conversion factors, things you need to know, we'll throw it into the problem. Okay, and so our last conversion factor is 1 kilogram is 2.2046 pounds. And so that's our final step. So we're doing 1 times, so what's our math here? So we're going 1 times 3.7854 times 1,000 times 0.7894, and then we're dividing by 1,000, and then multiplying by 2.2046. And so the gallon of ethanol is approximately 6.59 pounds. The density of water is a little bit greater than the density of ethanol. It's 1 gram per milliliter. So the mass of a gallon of water is going to be about 20% heavier or so. So a gallon of water is about 7 to 8 pounds. And then the next conversion gets into a cubic conversion factor. And so the idea of this conversion is that if you think of 1 cubic meter, so imagine you have a cube, not a great artist, but I think you can picture 1 meter by 1 meter by 1 meter. And if we want to convert this to centimeters, that'd be 100 centimeters by 100 centimeters by 100 centimeters. So how many cubic centimeters are in 1 cubic meter? Well, it'll be 100 times 100 times 100. So that's 100 to the 3 centimeters cubed in 1 cubic meter. Okay, now how do we know, or how do we use this conversion factor? Well, if we ever need to convert the centimeters, 100 centimeters for 1 meter, if we need to cube the conversion, we have to cube the entire conversion factor. So 1 cubic meter is 100 cubed centimeters cubed. All right, so that'll do it for this video. We'll talk more about these conversion factors and other problems in class.